Hello and welcome to the Sub 1 YouTube channel. My name is Ray, and in this video part 10 of the Robo Hat design. I've got these boards assembled. I did that in the last video, but since the last video I've actually installed all the through-hole components. Now what we have are these boards which I added all the components to in the last video. Before we go and power these boards up, and in fact before I added all of these through-hole components to the boards, one of the things we need to do is a couple of basic tests to make sure we're not going to blow anything up, like our Raspberry Pi, in this case 4 or 5 if you got one, although these should run on a Raspberry Pi 3 as well. So we're going to start with some very basic type operation. So we need to make sure we haven't got any major issues. So we're going to put our multimeter into ohms, and we're going to measure on this 40 pin header. We're going to measure between the second on the bottom and the third on the bottom, and we should get around 20k ohms on the multimeter. So 19.94 is close enough. Now the reason we get that 20k ohm is because we have in our schematic, and let me just see if I can bring that up. Okay, so in the schematic we have these two resistors on the 3.3 volt SDA and the 3.3 volt SCL, which are the two pins we're testing across. The idea behind that is, well, they're pull-up resistors, obviously, so they pull them up towards the 3.3 volt line. And we're testing between that pin and that pin to make sure that we can see a series of those two resistors, which 10k each gives us 20k. If we then measure between 3.3 volt, which is the end pin, and each of these two pins, we should see 10k. So let's okay, so if we measure between this 3.3 volt line and this line here, which I think is SEL, we're getting 10k, which is what I'm expecting. I must have been shorting across the other pin there. And if we try this one, we also get 10k. So that means that we know that the SCL and SDA on the 3.3 volt line are correct and are what we're expecting. Now, if we check between the SCL, so on the underside of these boards, we know that SCL and SDA are the two outer ones, which are up here. If we measure between those two, we should get 20k again, which we have. Now if we measure between one of those and the 5 volt line, we should get 10k. And same with the other one. So that proves that the circuit after the voltage shifter or the level shifter is actually correct as well, which is good. Now the other one we want to look at is ground, and this pin here from memory is ground. It's the third one on the top row, and the 3.3 volt line, and what we're seeing is 3 meg ohm. So anything over a meg ohm is good, and that's what we're looking for. So we know that those lines are reasonably clear. If you've got anything other than 3 meg ohm, or anything less than a meg ohm, then there is a possibility of a short. Okay, so on this board, what we're doing is we're going to check between the two pins on the end here. I've already mounted my through-hole components and my capacitor here, and I've hot glued this into place so it doesn't move, which is going to make this demonstration a little bit harder. But we're testing for resistance between those two pins, and we should get something that's, up fairly high, because we haven't got pull-up resistors on the line at this point. If you plug it into the other board, once you've put your headers on, you'll get 20k ohm or thereabouts. The other thing we want to have a look at, and we can do this from the other side, the middle pins are all going via these two or these resistors. This is the correct size resistor now. It's an R or a 0.005 ohm resistor, which gives us the voltage we need, or voltage drop we need to measure with these chips at around about 8 amps. It'll give us 14 microvolts, which is what they're looking for. So what we're looking for here is, well, there's our positive pin from our power supply, and we're just checking to make sure, and it's easier to do it from the underside for that reason. So that's our positive pin there, and we're just checking to my multimeter went to sleep. We're just checking to make sure that there is a circuit through to here that, in this case, it will be less than 0.1 ohm. And I'm not getting a very clean connection to it. So you can see that did go to 0, and we've got to do that for all of the pins. It is much easier to do before you put that header in, or that set of headers in, and I did do that before I put the headers in. That just shows that there is a circuit through all the way through. Now, something else that you need to be aware of, depending on the design of the robot you're using, these are set up to monitor the current flowing into this pair of headers, this one to this pair, and it continues on that one, this pair, that one, and this pair. Now, with these jumpers here between the resistors, there is a shorted link between here and this pin. If you cut that short link and then bridge across on the other one, you'll get these three will be on that one, and this one will be on this one. And it works in pairs all the way through the board. So that's an optional change you can do. I'm not going to do it at the moment. I think I'll be able to use it on my robot dog the way it is now. Alright, so our next test is going to be to power it up. One of the things I did before I connected it to my Raspberry Pi is I connected 3.3 volt from my test power supply between the ground pin here, which is the third one on the top, and the 3.3, making sure that's 3.3 volt. You should only draw around about 0.19 amps or 190 milliamps. Anything more than that and you've got a problem on the board, you're going to have another closer look at it. Check all your chip alignments and all that sort of things. If you've been alright on the SDA and SCLs, you're probably okay. Alright, so once we've done our quick power supply test using our bench power supply, let's hook it onto the Raspberry Pi, making sure all your pins are aligned correctly. And we'll put in some standoffs to hold it in place. You don't need to overdo these standoffs as far as tightness goes, just get them down close. I even back them off quarter of a turn after I hit the end. They don't have to be overly tight. We don't want to damage anything in the process. And try not to cross thread the screws. They are an M2.5. Now, once you've got these all in, you can power it up if you want, but just bear in mind that you're not going to get a response from any of the current monitoring chips, and there are 8 of those. If you find you've got a problem with nothing responding, then it might pay to pull this second board off. Now I'm going to plug this on, again making sure all the pins are aligned correctly. So you end up with this header connected, and this header will be connected. And then we can power it up. If all goes well, you should get a blue light. That means that we've got the 3.3 volt working fine. No issues there. There should be no smoke. For those of you who smoke, please don't. It's not good for you. And it's definitely not good for the electronics. If they're smoking, it will kill them. The green flashing light indicates it's accessing the micro SD card, and so it's booting up. So our next trick is to either connect up a monitor and keyboard and mouse, or to connect into it with VNC if you've already set that up, which I have. So I'm going to switch over to that now. Okay, so with the Raspberry Pi booted up, let's go to our terminal window. And in here, we're going to type in I2C detect -Y1. And that didn't work. Why didn't that work? I2C detect -Y1. So that tells us to use bus 1 and to proceed with the testing. And it should come back with what you're seeing here. So 20 is the PCF 8574. On at 40 through 47, we have our INA 219s for our current detection. 48 and 49 are the two ADS 1115 chips. 50 is the PCA 9685. Those of you who are familiar with that on breakout boards, normally it defaults to 40, but I needed 40 for the INAs, so I moved it up to 50. Right down here on 5A is the MPR 121. At 68 here, we have the MPU 6050, and right down here we have 70, which is the default address for the global control of multiple PCA 9685s. By default, this is enabled. You can actually turn that off in the software by sending a command to disable it. You can actually turn on 3 more of them, but by default it's there. I don't advise you putting any I2C devices onto that address, and I have previous videos where I've moved them up to 71. Alright, so having done all of that, I'm reasonably confident that there's no major issues on the board. I have since found one more issue on the board. That one more issue on the board was actually that output enable resistor I spoke about before. So that'll do for this video. In the next video, I'm going to show how to use the MPU 6050, and the video after that I'll look at the PCF 8574, and by then I hope I'll have a video also ready to go for the PCA 9685. To see when those videos come out, don't forget to click on like, subscribe, and ring that notification bell. It's also a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to support the channel further, I do have a Patreon account, and you can join my VIP patron Go Lucky, my All Access patron Jeff Jerd, my Builder patrons Al Morales 45, Andrew Cardone, Airgar69, and Stefan Paps into supporting the channel. I also have YouTube membership if you'd like to support in that method as well. If you have any questions, don't forget to leave a comment below or drop into the Discord. There will be a link in the description, and ask your question in Discord. If I can't answer it, someone else might be able to. and we'll see you in the next video.